Hey everyone, this is part 3 of my anti-tutorial on how to program asteroids in C++, and this part will be a lot less structured. Most of the parts from here on out will be a lot less structured because I'm learning while recording this. So in my last part I talked about how I plan on doing stuff, and this is the first part I'm actually going to create something rather than show off what I've done so far. So the first thing we're going to create is a class for our game object that we can inherit from, which is a superclass, and we're not going to make any instances of it, so it's basically just a empty template. And we are going to call it game object because that's what it is. And we're going to have private stuff, which is well, we need to make it protected, I think, because we want inheriting classes to have the same things. So what we need is we have a x and y coordinate for our object, which is its location, and if we change location, the object should move. And we want to have an angle for rotation, so we're probably going to have an angle, and we're going to have a pointer to some points, a pointer to some points. No, a pointer to an array of points, where we will store the outline of the thing. So if we check out my main file I've written this for, this is basically the format how points are declared. So GL float an array. The Z coordinate is always 0 because we have a 2D game, so we don't need a depth component. So basically we're going to copy that and care about how things are stored in there later. So, and because we don't have included the proper library file, it doesn't recognize it. And now we are good to go. So that's basically what we want to have for our variables. A game object has a position, it has an outline, and it has an angle for rotation. The question is, do any other game objects rotate other than the ship of the player? I don't think the asteroids rotate. I don't think the ammunition, the projectiles rotate. I don't think that the enemy ship rotates, like the, I don't know, the alien ship. I don't know the correct word. Unidentified flying object, UFO, whatever. So I don't think any of those things rotate. So we could just make a game object player ship and extend it with a float for rotation, so that's probably our common denominator. What we're going to have is a get position and a set position. They will both return a float. So we can now get our position and set our position, and no, set position will not return a float. I don't think set position will return a float. It will take two floats. So basically we have a float X and a float Y. I'm thinking about whether to call them this. No return. Whether to call them this, because I don't like it if the argument of the method has the same name as the variable used inside the object. But for now we'll roll with it. We can change it later. It's not so important. And we're going to implement them quick. Um, okay. So what get position will do is it will return a float. So how do we handle that? We could use a library and just make it a tuple, like pair it up. But I'm not sure if that's a standard library, so I'll look that up for you. So we have a C++, um, uh, what word did I just use? So basically we want to pair up, so we want to make a pair, and we'll have a look which library that is in. Okay, it's that wasn't helpful. Pair is this thing called pair? Okay, so it's in utility, but I don't think I'm supposed to use utility. So what we'll do is we have a boolean basically. We will make here a bool choice. So basically, if choice, then we will turn x, y, and else we will return x. So basically, if you give a negative, it will just return the first, and if you give a positive, it will return the second. So O is the first and 1 is the second, which makes sense from a programmer standpoint, I hope. So we will have to extend our declaration accordingly, which makes the red lines go away, which always makes me happy. So, and we probably want to have the ability to initialize a game object with 2 floats, so you don't have to set them afterwards. So what we're going to do is we're going to write a constructor for that, and we will set this x is x and this y is y. So we have our internal variable is the argument, and then our other internal variable is the other argument. So we don't need to set them, and the default constructor, those are not set. So you can basically use the default constructor and use set position afterwards, which does kind of the same thing. As soon as people start watching me, my ability to type goes against 0, which is fine. We'll manage. So that's really all our objects need to do at the moment. That's I think what every object needs. Rotation is ship specific. Spawning into smaller asteroids when this asteroid is asteroid specific. Appearing at random times is probably alien ship specific. So yeah, I think we're good with that. Okay, the next thing we need to think about is that in asteroids the play area is actually a sphere. So if something leaves on the right side, it appears on the left side of the field. And if something appears at the top, it left at the bottom. So we could either have the movement handle it. So if you move an object in the physics handler, so if you move an object and it goes out of bounds, so to speak, on any of the sides, you move it to the bottom left. You move it to the opposing side and move it accordingly again. But that's kind of not the responsibility of a physics handler, so to speak. So my idea was to create a class for our game field, for our board, that actually handles that stuff itself. So basically you have an object that has a position. After it's being moved, you can call a method of the game field and it translates the coordinates accordingly. So if you're out of bounds at the top, it will set you at the bottom left and you can always check back. And if you translate the model into the view, it will be translated accordingly. I'm not sure how that's going to work out, like in the structural grand scheme of things, but I think it's a cute idea, and I'd like to try it. So what we're going to do is we're going to add another class, and we're going to call it, I don't know. I don't know what to call it actually. It's not a map, it's not a board, it's not a playing field. Oh, that sounds stupid to me. Oh, we'll call it game board nevertheless. And the game board has I think it needs to have 4. Well, if we're going to assume that the origin, so x0 and y0, is actually in the very middle of the field, we could then just have the cutoff point declared once. If we're going to assume it's a rectangle, we could have 2. I'm actually not sure. I think the windows by default are a rectangle, and I think the original is a rectangle as well. So what we're going to do is we are going to define a cutoff for x and a cutoff for y, and we're just going to assume that the positive and negative cutoff are the same. It would make sense for the 0, 0 origin to be in the middle of the rectangle at least, right? So we don't need 4 points, 4 lines of cutoff. So we're going to declare them via the constructor as well, and we can use a short version of that. Cox and Koi. Strange to look at, whatever. And we're going to implement that constructor. And we're going to set cut off. We should probably use this one, but it's not really necessary. So now we know where the cutoff is. We could theoretically, if the okay, that's kind of a stupid idea. If we resize the window, everything should get bigger, right? But if it doesn't, the game board increases in size. So we could theoretically program the game board in a way that makes it possible to resize it on the fly, but I don't think that's advisable. The standard constructor bad. We don't want to use that. But if we use it, we could use a set cutoff x and y, but that's kind of stupid. I'm not sure. I think I'm going to go with the standard getter and no setter, so you have to use the constructor with a float arguments. So what we're going to do is float as a get cutoff. And it's going to take a bool choice, as we know, and it's going to either return A or B, cutoff X or cutoff Y. So what we have is a float in the game board. And if choice, we're going to return cut off Y, and else we're going to return cut off X. Right, so for 1 we have the second one, and for 0 we have the first one. Okay, so what else do we need? We need a translate method. So basically we have a point. I should probably write a point class, or at least a struct. I don't have to deal with strange stuff then. Should I write a point? Well, it would make sense. I could give back the cutoff as a point. I could set the position as a point and get the position as a point. Probably would be useful to write a point, right? Okay, we're going to add a point class. Do we need a class? Does it have to do anything? Why not struct? We're going to add a struct and try. If it doesn't work, we're going to try a class. So we're going to add a new element, and we're going to make it a header file, and we're going to call it point header. And we're going to make a struct called point. Do we want to have it? Do we want to have it capitalized? I'm not sure. I think I like lowercase better. Will come back to bite me in the ass, always does. So, and what we have is a float x and a float y, because that's how I like to name my points. Point coordinates, so to speak, and it doesn't really have to do anything. We could use a type def, so we don't always have to type struct. Do we want to use a type def? C++ type def. Google's my best friend. Type def specifier. Do we want to do that? So basically, it's a common C idiom to avoid having to write struct as. So basically we're just going to add type def to the front, and we're not going to have to write struct, but we can use point directly. Is that right? Okay, what I thought about just talking to you guys is there already a point? No, isn't. Small one as well? No. Okay. I'm not always too sure. Holy shit. I'm not always too sure what isn't in these standard libraries. And I'm not too sure if you can like look it up or have it memorized the stuff, so I'd rather try than do work twice. Okay, so we have a point now, which is x and y, and it doesn't do anything fancy. That's great, actually. I like that. Okay. Now back to actually using it. We're going to include It worked. Why copy it around, right? Why copy it around when it worked? Don't want to mess anything up. So never change a running team. Running, winning. Never change your running system, never change a winning team, and don't mix up stuff. Always comes up bad. So what we're going to do is we're going to add the point in here because I think everything needs this point. It's just great. Points are amazing. Okay. What we're going to adjust is we're not going to set a position with two floats. We're going to use a point, and we're going to use a small one. And we're going to call it P because points are always called P, right? And we're going to return a point, which is amazing. And we no longer need the choice. And we can use a point as well here. Point P. Okay, we're going to have to adjust to this, so we're going to have a point P. Let's call him P again. Okay, why do we need a point here? We should be storing the information in the game object already as a point. So what we're doing is we're going to make a point position here. That makes a whole lot more sense, and it's going to be small. Okay, so what we're basically doing is return this position. Okay, and we're going to have a point P here. I kind of have the urge to always write point in capital, so we're going to change that, because I don't want to end up retyping every time. So we're just going to change it once, and then I'm going to change my mind and we're going to change it another time. I always see that coming. Okay, and we're having a point P here, and basically we're setting it to P, X, and Py. Why did I remove that? We could have used it. Okay, question. Could we use... that's wrong. Could we do it this way around? Could we use this? Set position P? Would that work? I'm not sure actually. Let's try it. So what we're going to do is here this as position, and position as an X, and this is going to be px, and this has a position, and it has a Y, and we have a py. So that's that. Forgot anything? Nope, I think we have that. So we have a point called cutoff. And it won't return a float, it will return a point. Here we have our point. And we will use a point here as an argument. And just do the same thing we did with the game object, which is basically this has a cutoff, and the cutoff dot x is co dot x, and this cutoff dot y is co dot y. Have we got any other points? No. Nope. 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 So what I'm thinking about currently is if we create the point, then we use it as an argument. It's a copy by call by value, right? It's not a call by reference, because if it's a call by reference, the memory could be deleted with the end of lifetime of our object, for example. So I hope it's a call by value. I don't think it makes any difference though. Way too late to think about that. Okay, we're just going to assume it works. It will work out like this. So what we have is a game board, and a game board needs to translate the position, which was where he got stuck with two floats and decided to make a point. Making a point, basically, to use a little pun in there. So we're going to have a translate, and translate is going to return a new point, and it's going to use a point which is position. So basically what you do is you call this with your position, and then it will give you a new position. So let's assume our cutoff is 1.0 as a float. What you are going to assume is you move in a y-axis direction, and you're at exactly one float at the very top of the screen, and you move one float in y-axis direction, positive y-axis direction, you're going to end up on 0.0 at the origin of the coordinate system. So you basically end up in the middle. And if you do the same in the x-axis direction, it will do the same. So what I'm currently thinking about is if we have a rectangle, our relations could be skewed, because 0.1 float in x-axis direction is not the same as 0.1 in y-axis direction. At least it could be. I'm not sure. We will have to try that out. If it's 1 for 1, if it's not the same in x and y-axis direction. So doesn't really affect the translate method though. So let's assume we have a position, and we're going to translate that. So we need a point which is temporary, and we're going to set that to position. So what we have is a position of the game object, and let's say it is not inside our coordinate system, but exceeds the cutoff. What we want to do is we want to subtract the cutoff until it is within our original system. So let's say our cutoff is minus 1.0 float to 1.0 float. We basically are going to subtract 1.0 float from the coordinate along the specified axis until we are within that region. So while temp.x is bigger than our cutoff.x, we will reduce temp.x by cutoff.x, right? So let's say our thing is at 3 float. We're going to cut off 1 float, which puts it in the middle, and we're still at 2 floats. So we're going to cut off another float, 1.0 float, and it's at a 1.0 float, which puts it at the top. So basically it threw out the top side, and then 2.0 floats in positive y-axis direction. So it basically went full circle. It started at 1.0 floats and achieved to go back to 1.0 floats. So let's assume it's going in a negative direction. So while temp.x is smaller than cutoff, we're going to have to do it that way, probably. So we want the negative cutoff, because the negative cutoff is minus 1.0 floats. So let's say it's at minus 3.0 floats. We want to have the same effect. So we're going to add on top the cutoff, and we will end up at minus 1.0 float, which is exactly where we want to be. I'm talking about a y-axis while typing x-axis, but it's exactly the same principle. So it needs to be bigger and smaller, not smaller or equal, because 1 minus 1.0, if our cutoff is minus 1.0 floats, it should cut off anything that is larger, so it needs to be smaller. So we're going to do the same for our y coordinate. Assuming that it follows the same principle. The hell? No, I was correct. I was correct. Everything's fine. Chill out. With the first doing x in positive direction, then in negative direction, then doing y in positive direction, then in negative direction. So we're reducing it until we are at the positive, and we're increasing it until we are at the negative. That's basically what I wanted to do with the game board. So we can have a cutoff, and we can translate stuff on this sphere. So if it goes 88.1 floats in positive direction, it ends up at 0.1 floats, which is exactly what I wanted to do. I don't think we messed up. At least I don't hope we did. So we have a game board. that can translate positions, and is a sphere, or represents a sphere. We can set a cutoff, we can read the cutoff, we can shuffle around the positions. So what we're going to do next is as the physics handler. We're going to make a class. We call it physics handler. And our physics handler has to have a private, which is a like a list of all existing game objects. So basically, every asteroid and every ship and every projectile needs to be in there. And we need to have a function that allows a game object to register itself with the physics handler. So on creation, the game object registers with the physics handler, and everything else is handled by the physics handler. I'm not sure about projectiles. Maybe projectiles should destroy themselves rather than the physics handler destroying the game objects. That's not really part of the physics handler. So registers game object with physics handler. That's the function we're going to write. I'm not sure how the list is going to look. We could use a linked list. Really simple. Thing is, we will need a struct probably. And the struct, I'm not going to come up with a name just yet. But basically, we will need a reference to. We need a reference to the game object, and then we will have I'm going to use this sort of point. We need a reference to game object reference, and then we need an impulse. So asteroids have an impulse that doesn't get smaller, and a ship will slow down over time. So basically what we need is an impulse, which is a point in essence. So we're going to have a point impulse. As I said, my ability to type goes against 0 as soon as I start showing something to people. Yeah, exactly. Array without a defined size, because we have in the, if you remember in the game object, we just have a array without a defined size. That's okay, we don't want to run it just yet, so that's fine. So we have an impulse, and probably we have a I'm not sure of the exact word, but basically we want to have friction. Okay, so friction slows down our object. So we have an impulse that exists, and we have friction that slows down said impulse. And we have a reference to a game object. I'm not sure how exactly you do a reference, but we can Google that. Reference object So we're basically going to go with that. Nice. Okay, it's a reference. So it's basically a business end. Okay, so that's how the things are registered. So you registered. I'm not sure how to pronounce that. Registered. So basically, you put a reference there, and you have an impulse and friction. So we're going to call it a physics object as a reference to a game object and has an impulse and friction. Okay, and how are we going to register them? So basically, we need to start them somewhere. We could do a linked list. So a linked list would be just to add a pointer to itself, right? So basically, we could have a starting point, and then we could iterate out the list. Do we need to search the list at some point? Probably not. I don't think so. We don't need to search the list. It's not going to be that huge. Do we need to insert? Probably not. If it's in the list, it gets processed. Sorting doesn't really matter. I don't think a linked list would be that bad of a choice. We could like make a hash map or something, but that's probably overkill because I need to program everything myself. So a linked list would be probably the best idea. But I'm not sure if I want to do it that way. I will do more research on that topic. So we have the basics of our game. We have a game board that can translate positions because it's a sphere. We have the parent for our game object, which defines the boundaries of what our game objects will look like. We have a position, an outline. We can set a position, get a position, can create them, just draw them. We have our physics handler and a kind of an idea what it's going to do. We actually got quite a bit done, I think. It gave me personally a bit of an overview of the project, like what I need to create. I'll probably go with a linked list here, but I'm going to do more research on alternative methods of storing that information and going over it. Well, linked lists would be simple, and simple doesn't break often, especially if I have to program it myself. I think I could fuck up a detail or two, and we don't want that to happen. So we'll probably go with something simple like a linked list. We don't need double linked lists. We don't need to go backwards. I think that's about it for the start. Could go back to the graphics, but I think I have everything from the graphics. We have the view's still in the child shoes to speak very softly of it. So basically we're going to bash every object, every game object with its outline. So basically the outline is an offset of the position, so we're going to add position plus outline 1 and bash that in here, and the next one and the next one, and create a line for the game object, and then I'm going to move to the next game object and register all points, register all lines, and to the next object. And that will be that will be our view. Yeah, so view, we're going to need to extract our key callback to the controller, and the controller. Oh, we should probably initialize the controller. We should probably initialize the controller because that's kind of a big deal. So we have a controller, and we have a private, and we will have a tick rate. I think we will go with a tick rate. Tick rate PS, so tick rate per second. And we're going to have the key callback shit. Don't say shit in something like this. Oh, I won't say shit. It's a bad word. Shouldn't use it. Okay. Yeah, we need to have here user input basically. We will have to probably do a game tick here. Don't write it now. Game tick is probably better. So with every tick, the physics handler does a calculation of the new positions and if a collision happens. And the user input is fed to the physics handler as well. So if the ship rotates or whatever, user input is probably going to create the projectile if we shoot, and the projectile itself is going to delete it if it flies for a certain time. Like if it has crossed more than 2.0 floats of space, it's going to delete itself or something like that. And we're probably going to have a variable for a maximum of shots a player can fire before the first one has to be a maximum of shots that can be flying from the player, basically. So you can only shoot 3 times, and if the first one gets deleted, then you can shoot again. Something like that. And probably game control is also going to handle the score. I'm not sure. I'm not sure where to put the score. I'm just going to write it here, but I'm not too sure who's going to keep the score. Maybe the object themselves, but that's kind of stupid. That's not a nice solution. I'm going to think about that as well and do some research. Game controller is doing the game tick. We have a tick rate per second. So as a reference, we need to do query performance counter to keep it hardware independent. So I think that's basically it. We have a game controller, a physics handler, we have a game board and game objects, and we have some kind of view that currently doesn't work, but it's a start. So I think we made quite the progress defining the outlines of the project, getting a sense for what everything's going to do. And we're probably going to have to adjust things, maybe redo some of the planning. But I really like what we've done so far. I think this could really work out. Even if I don't sound like it, I'm having quite a lot of fun figuring stuff out and thinking about the possibilities. And I hope you guys are enjoying it as well. So stay tuned and maybe try something yourself.